Yeah, my name is Jose. I'm part of the space operations team at Planet. Our mission is to take care of our satellites, our Earth observation constellations, and essentially capture and deliver as much data as possible for our customers. Today, I'm going to give a brief overview of Planet's constellations and our products. And then, like I said, I'll focus on how we automate operations to be able to deliver those products. This is one of Planet's mottos, if you will. You can't fix what you can't see. An important part of Planet mission is to provide visibility and accountability of everything that happens in the world from space. So that's why it's very important for Planet to provide global daily coverage so we can see changes across the entire globe every day. To do that, we have the SuperDoves. I'm assuming most people here will be familiar, but just in case, you can see the satellites there. It's basically a 3-unit CubeSat with an 8-band visible and near infrared sensor with a 3.7 meters approximately ground sampling distance. These satellites, they're very small, very scalable. We have almost 200 of them on orbit at any given time, and that's what enables us to get global daily coverage of the world. We complement that with SkySats, which are our high-resolution product. Unlike the SuperDoves, which are constantly imaging, monitoring the entire globe, this is a tasking mission. So here we're focusing on areas of interest for our customers for the most part. But they work hand in hand. So for example, you can monitor changes with SuperDoves and task the SkySats to get a higher resolution image of that area. Those are workflows that we're very familiar with. This here is just a little graphical visualization of how the orbits look like. You can see the doves there. They are in sun-synchronous orbits to basically enable that global coverage throughout the day as the Earth rotates. The SkySats are both in sun-synchronous orbits and also in 53 degrees incline orbits that you'll see in a second to enable more capacity in their lower latitudes. You can see there. So this gives you an idea of how many satellites we have, and of course why automation is very important. We'll touch more on that in a minute. Before that, I want to stress out that Planet is not a satellite company. Planet is a data platform company. So our main goal is to provide data to our customers. They don't necessarily have to care about the satellites, although I, as an engineer, do. And that's mostly what I'm going to be talking about. But here you can also see that Planet not only offers images, but also insights via in-house solutions and also in collaboration with partners. We do things like building change detection, road detections, detecting vehicles, or deforestation as well. So the large amount of data that we capture enables all of these machine learning approaches as well. Of course, this has a ton of applications. We've listed some here, ranging from defense and intelligence or civil government to agriculture and forestry, but also informing financial decisions, insurance decisions, or helping with managing natural catastrophes or other emergencies, among other things. In order to do this, one of the foundations of Planet's history is agile aerospace. The only way to ramp up such a large constellation in such a short amount of time is to essentially not be afraid to fail. We've launched hundreds of satellites in the last few years. every time that we launch, we test new capabilities, new hardware, new software. Sometimes it works, sometimes it doesn't. We learn from it and we repeat it pretty often. That's kind of what we understand by agile aerospace. We apply this to hardware, we apply this to software, and also to operations. And yeah, among other things, that allows us to have done 14 distinct DOF builds in 6 years. So again, every build informs the next and the design of the next. That means that we have like a 3-6 month design life cycle. We can add new components if they're available from the industry very quickly. We can iterate on the design to improve either the satellites themselves or the product. And in the topic of operations, which is mostly what I'm going to be talking about, we follow a very similar approach. The super DOFs, this is a little graph trying to show the concept of operations of the super DOFs. Before diving into this, the basic concept is actually very simple. If the super DOFs, if they're over land or over certain areas of interest in the oceans as well, we are just imaging basically all the time. And then when we are in contact with the ground station, we're downlinking those images to the ground for publishing them to customers. That sounds much more simple than it is, of course. Among other things, the ground stations are also responsible for maintaining the health of the satellites, commanding the satellites, and so on. We're talking about hundreds of satellites and dozens of ground stations across the globe. So obviously we need a centralized entity that controls all of this. That's our cloud-based mission control that you see there on the bottom left. The scheduling is a very big piece of the puzzle as well. We need to know what every single satellite and every ground station is going to be doing at any given time. I'll chat about that a bit later as well. And then it's not enough with just downlinking the data. We have to store it, process it, and deliver it to customers, either in the form of imagery or some of those analytics that I was mentioning before. Okay, you can already see that this sounds very different from quote unquote traditional satellite operations. Space is pretty hard, and especially until 5-10 years ago, satellites were very expensive, very complex. They require very labor-intensive operations, very manual, with large number of operators looking at a single satellite 24/7 often. Just looking at raw telemetry or raw logs from the satellites. And that obviously has to change when you have the scale of satellites that we have. So that's where automation comes into place. We're still looking at the same sort of data. The difference is that now, instead of humans manually looking at it, we have automations, robots in the loop, taking most of the operational decisions for us. So that's what I want to focus on. I'm going to go through a few aspects that I think are important to automate in our case. Yeah, we can start with commanding. That's very important. You need to basically tell the satellites what to do and make sure they are healthy and operating nominally. So we have, like I said, we have a lot of satellites, a lot of ground stations that ends up amounting to thousands of antenna, like ground station to satellite contacts every single day, often several of them at the same time. So obviously you cannot command the satellites manually during those. So all of the communication with the satellites happens autonomously with no human in the loop. The data from our sensors comes down autonomously as well. The scheduling that I mentioned before is also automated. You basically, the imaging problem is tough to optimize because so for example, for the case of the super DOFs, you need to cover the entire globe every day, basically. So imagine like a line, every satellite is like a line scanner that's scanning its ground track. When you multiply that by more than 100 satellites, you basically need to make some decisions on what area each satellite is going to be imaging in order to maximize that coverage. And also at the same time, you need to optimize those ground station contacts so that you get that data from space and into the hands of our customers as quickly as possible with the lowest latency possible. So yeah, that's a pretty complex optimization problem that happens autonomously all the time. The same for SkySats. In that case, the tasking requests from our customers need to be aggregated and actually materialized into imaging opportunities. And that has to happen autonomously as well. Okay. Then, like I said, downlinking the data is not enough. That data flow has to go not only to the ground station, but then be stored in the cloud and be processed in the cloud as part of our pipeline. And then eventually that is delivered to our customers, again, either in the form of imagery or derived insights. Other things that we have to care about are taking care of the fleet. All of the satellites go through frequent, for example, flight software updates. These are rolled out autonomously as well. We do automatic maintenance activities as well on certain cadences. And then the third bullet point there is pretty important, I think. An important paradigm shift, I think, is to stop caring so much about the satellites at an individual level and think more about the total performance and productivity of the mission entirely, or the constellation. So it doesn't matter so much what the performance of a single satellite is, but rather optimize every satellite based on how they perform to maximize the total output of the constellation. So that fleet-wide optimization, I think, is very important. Okay. Then we also have automated anomaly detection and reaction. There are some anomalies that we understand very well from having deal with them manually at first. We know how to mitigate them. So that detection and the reaction, and then bringing the satellite back into production, it's all streamlined and automated. So that happens without any manual intervention. Then, of course, you sometimes get anomalies that are not understood or we haven't seen before. You need to have a way to detect those as well. So we have metrics, machine learning tools to help with that, so that identification of anomalies is much faster. And in the end, what this means is that a very small team of engineers, even without having to look at the satellite constantly, because there's just too many of them, the turnaround in fixing and mitigating anomalies is very, very fast, because a robot can act 24/7. Unlike us. You were mentioning conjunctions and space traffic before. That's obviously very important, and with all the constellations that are flourishing, including ours, it becomes more important every day. We use data from our own GPS and ranging measurements to generate our own orbital predictions. So we publish that ephemeris data publicly. You can see it if you Google it, or I can also share the link if you're interested. That's mostly so that other operators can use it to screen conjunctions against their objects, and so that they have the best and latest data possible to avoid any issues. We also screen all possible conjunctions, both with external and internal orbital sources. The reaction is automated as well, of course. SkySats, in the case of SkySats, that's propulsion maneuvers. In the case of SuperDoves, we use differential drag, basically change the drag profile of the spacecraft to alter the orbit. Okay. We're launching pretty often. We normally have at least one launch a year, sometimes more. The launches are often large flocks, like 30, 40 superdoves. I think in the past we've launched up to 90 superdoves at once. Again, similar to nominal operations, you need to automate a lot of the ramping up process of those satellites so that it happens autonomously. That's also how we are able to bring satellites from launch to producing imagery in a matter of days. And that involves bringing the satellite from the launch to a stable position, deploying the panels and so on. Start acquiring imagery and calibrating the telescopes and the sensors. And then last but not least, I think this is actually very important, and what enables a lot of the other things we do is generating metrics and doing a ton of data analysis. So we have thousands of metrics analyzing everything from like very low level performance of individual satellites, like, you know, thermal power, other engineering stuff, to much more high level, like constellation wide key indicators like coverage and latency that I was mentioning before. And then everything in between. That's, I think, what enables identifying pain points or bottlenecks or really anything that's hurting the productivity of individual satellites or the fleet in general, and basically unlocks like further automation, further improvements, further optimization to be able to squeeze like a little bit more of productivity from these satellites. So if you sum all of that and some things that I might have forgotten, you get essentially fully automated nominal operations. Manual intervention is, excuse me, very minimal on our satellites once they're launched. And in turn, that's what, again, basically lets us maximize the productivity and efficiency of the fleet, and in the end, deliver more data, better data to our customers, which ultimately is what we really care about and what the customers care about. So yeah, that's really all I had. Again, if you want to reach out to me, my email is there. I think this presentation is also shared. So yeah, let me know.
Perfect, amazing. So thank you, Jose, for this, again, 360-degree overview of the planet's constellation and the management process that goes behind it. There are many questions, I think, in the chat, and I have some questions from my side as well. So I think let's go with the audience's questions first. There's Antonio that has several questions to you. So one question is, does Planet use cloud computing service from third party to process the image data? That's a question.
Yeah, we host all of our data on the cloud. I'm not sure how many specifics I can share, but we do use external third parties that I'm sure everybody's familiar with.
Perfect. So automated commissioning of new flocks includes a repositioning of all old satellites, targeting an optimal fleet. So I guess that's a bit complicated question.
Yeah, that's a very good question. Again, for the superdoves, we use differential drag to basically alter their orbits. When they're launched all together. Like the launcher just drops them. And they have to separate in the orbit so that they can capture more of the globe within that orbit. That happens using differential drag. It takes a few months to basically space them out evenly across the orbit. If you're interested in that, I know we have a published paper. I can probably dig it up, or maybe you can, talking exactly about that. It's an interesting topic, I think.
Perfect. So today, earlier, we were discussing again on the space junk panel some new regulations that have been put in place for small sats and the orbiting. So there's a 5-year end of life new regulation that came in, which again, it's subject to change, as players said, right? So in the near future, but how is that affecting Planet, Jose?
Yeah, that's a great question as well. Yeah, we're thinking about that a lot. Most of our satellites, basically all of our satellites, re-enter within 5 to 10 years. Our future constellations that we're currently designing, all of our future constellations are going to have propulsion, and they're going to have those requirements baked into the mission, basically, which at least personally, I think those requirements make a lot of sense. So yeah, we're very aware of them. Yeah.
Okay, perfect. So next question, there is another question from Antonio once again. So how many DOEs and super DOEs does Planet manage in space? That's a question.
Yeah, the figure that you saw before was 180. So we're normally sitting around there. Some of them re-enter or are retired for some reasons throughout the year. And normally every year we have a launch to replenish the constellation. It's been pretty stable around that figure for a few years. They're all super DOEs now, by the way.
Perfect. All right. So the next question then from my side, Jose, is what are some of the biggest challenges and opportunities that, let's say, Planet Labs and other small sat operators will face in the next coming years, from your standpoint?
Okay. I think space debris will be one. We already talked about that. So yeah. I don't know. I think the competition is pretty fierce. There's a lot of providers that some of them are way in the constellation phase already, others are in development. I think that's very healthy, and ultimately more data is better. I think the future of the Earth observation industry will be a blend of different sources, different bands, not only visible and infrared, but also hyperspectral, radar, SAR, you name it. And I think blending all of those together and eventually, like essentially providing more insights to customers. So many customers, I think they don't necessarily care, definitely not about satellites, but not even about images. Like they just want like a timeline over time of a given metric or whatever. I think that's where the industry is heading to. There's a lot of room for partnerships, I think.
I see. That's a good point. So another follow-up question on that, as you brought up the competition being there fierce and a lot of players now entering the EO market, right? So my question is, now that we see a lot of those players entering the EO market, right? So is that really necessary? Are those new players really necessary? Are those players just jumping in on where the cash race is, or it's really solving those solutions? Or if, let's say, those companies were not coming in, would the existing companies, let's say some of the leading providers that there are, still be able to provide the data and insight to the, again, decision makers on the planet?
Yeah.
So is there really need for so many new players? Yeah. That's a question.
I don't know. I think more competition probably brings the best in all of us. So that in that sense, it's good. There's also, like I said, different sensors, different capabilities that are just different across different satellites, different constellations. So if you're bringing a specific niche or a specific type of sensor that wasn't developed at this level before, and I'm sure there is stuff like that. Like there's SAR, there's higher resolution imagery. There's, I don't know, a lot of things that I'm sure there's still room for other players.
I see. Perfect. So there's just one more question from the audience, and with that we will be able to conclude the session. So the question is, as you have automated most of the nominal operations, what is the manual intervention ratio to satellites? So basically, as you have 180 satellites, do you still do manual monitoring? If so, what is the ratio to satellite automated to manpower ratio?
Yeah, I don't know how to put a number to that, I guess, but I mean, I can tell you that our team is a pretty small team. We're like 10 engineers, and we're taking care of like a couple hundred satellites. So the ratio there is pretty pretty high. Also, most of our, like the vast majority of our time is developing new automations, new solutions. It's not actually debugging individual satellites or things like that. So the downtime is really, really low. And most of our time is automating our job, basically, rather than actually acting on individual satellites.
Perfect, amazing. Yeah, I mean, so thank you once again, Jose, for the presentation. And generally,
Thank you.
Planet is a great company. We know. I had the pleasure also last year to speak with Mike Safian. So he shared the inspiring story how 8 individuals started the company from the garage. So that was great as well. So started from the garage and now have this hundreds of satellites in orbit. So that's really amazing. So amazing story as an inspiration for all other companies out there. So thank you once again, Jose, and we'll be happy to see you again next year, as we said. So we can discuss that a bit later after the conference. We can catch up regarding that. So thank you once again.